Yes, please, yeah.
So good afternoon, everybody. It's my really good pleasure to be here. And I will spend some words to tell you who I am, where I'm from. I was born in China, and I had my university education, master education in China, solid state physics and metal physics. And then I came to Chinese University of Technology in Gothenburg to do my PhD. I was on microscopy and microanalysis of semiconductors. And during that period of time, and after I finished the semiconductor, I moved to superconductors as experimental work, and then moved again to superconductor films and biomaterial systems, model catalysis systems, and eventually now I'm working part-time on semiconductor physics to produce new lighting source. At the same time, I work in a company to be responsible for technical development to develop another kind of lamp. It's really my pleasure to be here to get a chance to present the work I've done in my spare time. It's my gratitude to George. He gave me this opportunity. So,
I beg your pardon?
well, the topic of my talk will be the electron and the positron. As usual, when we talk about electron and positron, we don't really talk both at the same time. We talk about the real one in our universe, not the other universe. I will speak more about the electron than the positron. When it comes to the connection of the electron and the positron, then I will point out what is a connection. Well, the basis is that whatever theory you have or description of the electron, it should be put on the same footing as for the positron. You cannot get it launched?
That's fine. You should press the screen. Alan's Dean.
Yes. This is very strange. Sorry for this. I've deleted, but somehow it came back again. It's not the wrong version of this, because when I was playing with it, it says this mode is called the electron. I thought that was funny. When we talk about electron, there is a mode for moving in with the electron. And then I will jump this fast because this is my name, Chiu Honghu. I'm from Gothenburg University, Department of Physics, Sweden. So, yeah, that was even worse. It was even worse. It was too playful. Yeah. The content I'm going to talk about is the paper I published sort of recently in Physics Essays. This is the cover page. You got the paper, and this is the cover page of the paper, and this is the brief content of the paper. The title of the paper is The Nature of the Electron. Sounds very I feel it's kind of in a way offensive, but anyway, I took the title. So I started the paper with describing the concept of the electron from the word when it is conceived into the history. How do you see the history of the electron? In two perspectives. One is like time sequence view. The other one is the event, the time sequence, and also the event sequence. And then there was sort of theories that have developed in the years. And then based on that, I asked myself, what is actually missing? Do we miss something? And it seems like it did. So and I was working hard to get a structure, and then to see if it's possible. Based on this structure, I can put all the properties of the electron into the structure. Well, more or less I succeeded with it, and see. And then this, I use this one as kind of working hypothesis. See if this is true, then what is going to happen? And then the formulation is going to be a self-consist test and as a consequence, so at the same time. And then afterwards, so we one itinerary, so we refine the postulate, we rewrite the postulate again, and I describe what is the implication of the work, and then I conclude with some comments. So, but I will not go like directly following this line, rather it will be kind of jumpy step. There will be a lot of things missing. Hopefully, one thing, if you can follow the text, if you have the, if you want to do it, or you can read it afterwards. Yeah, but the whole thing is actually based on this equation, and let's see. It's probably difficult to visualize in advance what this equation is. Actually, it's the parameter equation for a moving strip, this one. And I got it from Herman Wild's book, The Concept of Riemann Surfaces, or the concept of Riemann surface. So, and then we'll come to change this one to the structure of the electron, I can call it. Because, as you see, you have two parameters here, the sizes here, and the rest is kind of phase, or time. So by varying these sizes, you have different kind of structure, so it's basically topological. Yeah, the outline will be, first of all, so the electron as we know it, what it is. And there I will not give like a technical justification for why we have to work on this thing. Because if, say, my reasoning is, like I remember Feynman said once, if you don't have one good reason, you need many reasons. In this case, probably you also need a lot of reasons to say, well, you have to work on this thing, or some other people don't think it's necessary. But anyway, I would just say, well, somebody think it was a question. And then I'd like to point out the two views. One view is a point-like particle, which is kind of orthodox view. And the other one is if we can find a topological structure which is not just a point. And then in following that, I will see what we call something simple. And then when the subtlety comes, set in the evolution of a simple structure, and then we eventually do something subjective, whether it's beautiful or not, is open for discussion. Then the postulate is, I name that structure as Hibbe's helix. The question is, will it be an electron or not? And then I will tell you, in this part, it will be the formulation briefly going through how we derive all the properties of the electron we have said here. And then, in terms of physics, geometry and topology, and then later it will be, I would like to draw your attention to say that this is a topological structure which has been overlooked, perhaps in mathematics or in physics, or by everybody or everybody else. And then there will be some discussion on, based on the structure, some discussion about art, mathematics and physics in terms of perception. And eventually I will come back again to give you the equation for describing the electron, in this parameter equation, with all the constants set. And finally I would like to share with you what is inside something I have thought after this work was done. Yes. So the way normally the electron is described was electron is a point-like particles. A particle, point-like. When you say it's a point, it's imprecise. This is because you cannot have a geometric point. When you say point-like, it seems like more precise. But